And now we're ready for higher degree equations, example number 2. And once again, this would be considered a higher degree equation because anything higher than a second power for our purposes is considered a higher degree equation. So fourth power would be the driving force behind this. This is indeed a higher degree equation. So again, back to the notes that we established in example 1, and I would encourage you to watch these in sequence. That's how they've been laid out. But anyway, if you go through the preliminary simplification of clearing fractions, distributing, and combining like terms, you'll notice that none of that occurs, but always check for those simplification issues. Once again, the variable is in one term here, so we can indeed use the inverse operation approach to isolate that x. So, just like example number 1, the operation that would be furthest down the list from x, parentheses, exponents, multiply, divide, add. I hope you agree that the add 273 would need to be counteracted with its inverse, subtract. So we subtract the 273 over to the other side. And again, this is only going to work when we are fortunate enough to have our variable in one term. We'll talk about what happens if it's in more than one term in a future example. Anyway, then we come back and we say, in the order of operations, you would do that exponent first, then multiply. That makes the multiplier, again, further down the list, furthest from x. So we counteract that with division. And I hope my arithmetic is right. So that would be x to the fourth power equals negative 91 at this point. Now this is the juncture where I always suggest to people that you think ahead as to the possible positive and negative values for x. All right? Now if you were to put a positive number in for x and raise it to the fourth power, positive numbers raised to basically any power come out positive. And that's a negative number over there. So I hope logic would tell you that x could not be a positive real number. So we eliminate that one. This is different behavior than example number 1 you're noticing. If we were to put a negative number in there for x and raise it to the fourth power, and again I want to note that that is an even power. So as you recall, when we take negative numbers and raise them to even powers, they come out positive, and that's a negative number over there. So that won't work either. Neither one of them really makes sense. Now that would be the approach I hope you would use to reason your way to this. There, as it's going to turn out, is no real solution to this equation. But if that didn't make sense to you, I've got a backup plan. So if you wanted to press onward, you could definitely say, well, all right, what math operation gets rid of a fourth power? And you would hopefully, just like the last example, remember and realize that a fourth root would be the appropriate thing to do here because, again, roots and powers get rid of each other. They're inverse operations. So this side becomes x. And again, just like the last example, if you can't find the fourth root key on your calculator, you could always do this. That number underneath there is implied to be raised to the first power, and so you could change that into negative 91 to the 1/4 power. All right, and put it in that way. Now, just like we did on the previous one, you'd want to put the negative 91 in parentheses and raise it to the parentheses 1/4 power. So again, I can't say that enough. Base in parentheses raised to the power in parentheses. And when you hit that in there, oh no! It gives me an error message. All right, I don't know what yours says. Mine says something like no real solution. But anyway, whether you realize that back here or whether you go put it in the calculator, you would eventually come to the conclusion that there is no real solution to this particular equation. All right, so that would be scenario number 2 in our notes. When we go to the behavior of the roots, we already looked at scenario number 1. Let's look at number 2 here. We have an even root. All right, a fourth root, fourth root, sixth root, eighth root, roots that are even numbers. And we're putting it on top of a negative number. So when you put an even root on top of a negative radicand, what just happened? There's no real solution then to that equation. So again, that combination of an even root with a negative radicand is going to lead to no real solution. And either your brain would reason that out, or if you try to put it in the calculator, you'll get an error message. So that will be example number 2, and now we'll take a look at scenario number 3 with example number 3. Thank you.